Welcome everyone. I'm going to keep this short, but I thought maybe just giving you some sketches and some demos here. Maybe you'll make some of the concepts covered, especially in that third lecture for blood and blood spatter, a little bit more easy to understand. So I guess we're really started off with sort of looking at passive falls, and I'll show you some of those in a bit, but that would be the ones that fall at 90 degrees and they're circular and whatnot. And then we started to look at in the third lecture a little bit more of splashes. So what you can kind of wind up with is a blood droplet that looks sort of something like this. I'm not much of an artist here, but if I see something like this, I know that the blood was traveling in this direction. And as far as like the labeling goes, this would be called the tail. And then this over here is called the head. So they're different points that you could kind of refer to on a blood spatter droplet. So what you'll often see is that, imagine this, if you've got a blood droplet and it's headed in this direction. Blood's a fluid, right? I mean, it's a liquid. So what you're going to have is almost kind of like a little wave, if you will. So if the blood hits here and some of it drags along the bottom there, you got some surface tension. Above the bottom, or the surface that it comes in contact with, it's sort of flowing over more blood. So it kind of pushes this way, almost like if I had like a little clay ball and I pushed it off in this direction, it's going to get thicker over here. And you usually will see the tail a little bit darker. So I had a black Sharpie because I'm just drawing on an old Amazon box here to try to illustrate a point, but you'll usually see darker tail than head, and that's because the blood's thicker. It's traveling in this direction. And a lot of times what you'll see is, remember at the very beginning when I was saying, hey, these things, they're often referred to as like exclamation points, and you get like a little dot in the front where, if you think about it, if you're like writing, if I were to say, wow, my little exclamation point, that's all I'm getting at. This kind of looks like a knocked over exclamation point. So this is also kind of like a satellite, right? I mean, you could almost make an argument that this is sort of like a spike and that's like a satellite, even though those terms are usually used like the passive falls. Now, does this always have to be in front? No, sometimes it just sort of tapers out with a thicker blood there, and then that's the energy. That's it. Sometimes you actually get enough to where it pushes some out, and it does get ejected out towards the front there, though. So I did want you to know that. Another thing is, if you were to look at, say, a bunch of splashes in an area, and you had something, I'm just gonna, for speed and the fact that, again, I'm not really much of an artist here. I know these aren't real good exclamation points or anything, but let's say that we had these 4 droplets, and we're going to refer to this whole area here as spatter. Well, we've got a length and a width, or if you were to run a line through what's referred to as the longitudinal axis. So say we walked in and I don't know, we come in and we see these 4 droplets on the floor. We could determine the origin. In other words, where the heck did the blood come from? Was someone standing way the heck over here, or were they standing real close? And the way that they can determine that is, again, if they run a line through what's referred to as a longitudinal axis. And just to kind of illustrate this point here, I'm just going to not perfectly figure out exactly where the midpoint is, but if you were to extend that line off into space for all these known spatters, what you kind of wind up with is something that looks like this. So this area here, that would be the origin. In other words, this is where the victim, person, defender, whatever, person who let blood was located at this spot in 2D. So if you run a calculation, I just kind of put it up in the lecture, but for this being an intro to forensics, we're not going to get too much further into it. We won't actually run the calculations. We'll do some with probability, but anyways, long story short, if you run a calculation, you can get an angle from this. And if you take like a little handy dandy protractor and you hold it up to there, what you could do is run the line off of there at the known angle into like three-dimensional space. So then I could know how far off the ground at this point the blood was let. So that's kind of important, did the person lay on the floor when they got hit and blood was let, or were they standing upright? And was it looked like the blood was moving towards the person or away from the person? All those things can actually give you a ton of information. So that's something to kind of think about that could come from this as well. Another thing is if we look at food coloring, Let me see if I can kind of illustrate these points. And I don't know. Of course I'm going to choose red, right? Because we're doing blood here. Let's just kind of take a look at something here. So if I were to, and I got my phone here set up on a little tripod that's not real sturdy, so bear with me and we'll see if this works. I'm going to just barely hold this and try to drop it. All right. So there's one single drop from basically just above this cardboard. And, that was so darn close. If I look real closely, there's like kind of some spikes that are, it's almost probably more from it soaking into the cardboard than actually being ejected. But, I got to look real closely. I doubt that's even going to show up well on my phone. Let me see if I can zoom in a little more. Perhaps you can see that a bit better. But if I take this out again, and that was from real close. I mean, I was shooting for about an inch, but just to illustrate a point here, I'm not going to actually make the measurement. I'm going to try one off to the side here above where my phone's at. Oof. That may or may not have gotten on my sweatshirt. Ta-da! Look at that rascal. I know you couldn't see from the way that I've got this set up on my tripod, but that was from basically, I'd probably call it maybe 2 feet off of my desktop here. Look at all this that we got now, right? So what I want you to first and foremost kind of see is this was real close. So this was at a low height. And we've got a relatively small diameter. So if I measured this width across the blood droplet here, it's food coloring, kids. Everything's okay. Cash is fine. But anyways, if I measure that, that's going to be a lot less diameter than the one that was just a couple of feet up. Now, granted, you can make an argument if this was 1 inch and this was 2 feet. I mean, that's like 24 times higher. But, we've got tons of spatter here. Let's see if we can kind of zoom in. And you can see that there's lots of satellites. Realistically, I think I got a little bit on my hoodie here. But, as I kind of move around, they're all over the place. And if we were to boop, boop, maybe that helps kind of see, the bigger picture. There's little satellites and spikes and spines that are all over. I was really surprised how far from almost circular. It almost looks kind of like a little star there or something, huh? But, again, if I were to take and draw, let me see if I, bear with me here. If I were to say, all right, well, here's this guy, here's this guy, here's this guy, it's not going to show up real well because I'm trying to draw a pencil across, food coloring here. But where they would intersect would be exactly where that point of origin was. And, being that I just did it, I can tell you that's exactly where it landed on my little cardboard guy there. So what should you get out of this? Well, I guess a couple of things. One, food coloring, blood spatter. It's fun. And two, if it falls from a higher height, that's going to make a much larger diameter than a smaller height, which should kind of make sense. Here's something else to think about that I covered in another lecture, but not so much that third lecture. Would it matter? I've got cardboard here. If I had like a scrap piece of carpet or if I had, a ceramic tile, or if I had hardwood, would that change what this impact spatter would look like? Yeah, absolutely. The surface, if someone was running around outdoors, if they were bleeding on grass versus concrete, you would expect to see the spatter look different from the surface that it comes in contact with as well. So another thing, I'm going to kind of push that aside there before I make more of a mess, that I wanted you to kind of think of was, let's take a look at some angles. So what do I mean by angles? Actually, let me draw on this guy here real quick. If I've got a surface and blood flows, boop, or hits straight down, right? I mean, that's basically what? 90 degrees, right? You know what I mean? If I measure that there, that's 90 degrees. So half of that, and I'm not going to get my protractor out here, but I'm going to kind of ballpark it, right? That angle there, that would be about 45 degrees, and then if we were to get a little bit lower than that, I don't know, we'll say it's almost half of 45. So, we're at 22 or something and some change. So say that's like a 22-degree angle. If blood flows or falls straight down, or if it comes in at an angle, or it comes in at a lesser angle, or if you get further from that 90-degree angle, that's going to change from that passive fall, the circular drop, quite a bit. And what we'll see is the blood droplet gets a bit more elongated or stretched out, or it's going to look a little bit more like an oval. Another thing to consider here is I've been kind of sketching in like, a floor, like the blood's just falling and hitting a floor. Does blood have to hit a floor? No, what if we had a wall? You could have blood that comes in, I suppose, at like a 90-degree angle, or blood that's coming down, or you could have blood that's going up. And you might have to look to see, man, what's going on with the direction of the tail, and which way was this blood actually traveling? So whether it hits, a vertical or horizontal surface, what those surfaces are made of, that can all factor in. So let's set this little doodle here aside. And I'm going to try to make a couple here. I'm not going to go real high here and blow blood droplets all over the place, but I'm going to do my best to get, this is what I'm shooting for 90. Okay, so that's pretty circular. And now, the way I'm going to change the angle, rather than like, or kind of do one of those, I'm going to try to hold this. I'm basically just like lifting up the cardboard here. I don't know if you can see what I'm doing. To about a 45-degree angle-ish. And about the same height. Now I'm going to go up a bit more. Go up a bit more. Okay, so now, again, I didn't do this with a protractor, and I probably could measure it out, but I just wanted to illustrate a point here. When I held this flat, the blood came down. This was, approximately 90 degrees. And then, when I lifted this up, lifted this up, lifted this up, I probably got close to maybe like a 10, 15 degree. I'm just going to kind of ballpark it there, like a 10, 15 degree angle that it hit at. And, you can see here that if this guy was somewheres in between, then this one just started to get a little bit longer. Let me kind of zoom in here too. I know it's cardboard and it does kind of soak up, but I think you can kind of see even on my phone here that like this part of the blood droplet, food coloring, it's darker. And it's actually a lot thicker. Like from where I'm sitting right here, I can see it. And if I look down here, while I didn't get like, a full satellite jump through, I got this like spike or the spine. It's soaking in pretty good now, but it was a lot darker before. I don't know if the cardboard was just kind of wonky there or what. This is definitely a lot darker on that half. And if you look at this one, we almost got a satellite here, right? This almost kind of broke free, but even this stuff here, not as, same viscosity as blood, but, we got a real nice stretch. So can you tell which direction these guys were flowing? Yeah, right? I tilted them up this way. We just saw that the blood was traveling in that direction. It was chasing its tail. If you look at this is a lot more elongated or stretched out than this here, which would be, pretty much like a passive fall. So, I don't know, hopefully that kind of helps. If there's something else you'd like to see, or perhaps I forgot, feel free to let me know, or find some food coloring at home. Explore. Till we meet again, bye-bye.